Welcome again today. We're gonna take a look at today's sorting algorithm, one of the like sorting algorithms that are known for a few years, and these days a lot of people want to implement this because this is called insertion sort. You usually use insertion sort when you play card game. It's really resembles the way the human arrange the cards on their hands whenever they want to play the card game. So let's think about how we can think of this problem. So first, let's think of what is insertion sort. So first of all, we basically start. We only have one card on our hand, five, and then later on we keeps moving our iterator or index, and you check, hey, is three is sort of as a key value, and you think, hey, is three less than five or greater? Oh, it's less than five, so we want to switch them over. You know what I'm saying? So after first iterations, I'm gonna switch to three and five. Later on, I'm gonna move to the key as number one, which is third value, and I keep checking. On my left hand, I have three and five. On the right hand of a chunk, I have all the numbers as following. So is one less than five? If so, switch it. Okay. And this one keeps going, right? If is one smaller than three, and we keeps going. Okay. Now is the key is two. Is two smaller than five? Yes. Swap it. And is two smaller than three? Yes. Swap it. Hey, is two smaller than one? No. So stays there. And then we move to the next key, which is four in this case. Is four smaller than five? Yes. And then it keeps going on. So I hope you kind of see the pattern here. We definitely need our for loop checking the index which keeps moving, and this is going to take care of the key value. And later on we're going to probably make another variable called the prev or whatever, the j, whatever you name it, which is the variable right before that key, and that key keeps decrementing. I'm sorry, the prev of that index of that value keeps decrementing until it reaches the index of 0, and that it keeps swapping to its neighboring elements if that is if the key finds anything that's greater than itself. So that's why the keys kind of find itself. So let's code it up in Java. There are many ways that you can think about it, but this is my solution. Public class solution. You just sort of make a class, and later I'm gonna define one static method that returns integer array called insertion sort. Insertion sort int an array, and then inside of this array, you definitely need our folder, right? Taking care of the iterates from the beginning to the end, so array.length, and I increment it. So, and then we want to set two variables called key, right? So key is an I, and then I want to cast a prev equal I minus 1 as an index. So first of all, key is going to start as from 1, and prev is going to 0, but later on, this key is going to be what? 2 and 3 and 4 and so on, and the prev is going to be 0, 1, and 2 and so on, you know? That's how I do it. And then I definitely need to use my, probably you can use for loop, but I prefer use while loop because while certain condition is meant, I want to do the following. So what is going to be the while solution going to be? So while so this is sort of inside of this is sort of the second step of our algorithm. So as long as we set our key and prev, we want to keep moving prev to the previous direction, and then we want to implement swapping if we find any value that is greater than prev. So that's the solution. If the prev is greater and smaller than 0, and if we say, hey, if array of prev is greater than array of key, then we want to do the following. You know what I'm saying? And later on, we do know that we definitely probably need to decrement previous I at some point, because that's how we update this prev values. And key is going to be automatically updated from here, right? Because we just only switch it up basically the values of this key. We don't like change its like the key originally, if that makes sense. So actually we need to also like update a key later, right? Because later on we also keep moving our keys to the previous value, because after you swap it, that's how we do it. But I'll explain it like one by one at this point, so that you won't forget it. So let's assume that this prev is still above index 0, and we find any element that is greater than prev. The key, prev in this case, you know? What do you want to do? We want to swap those two values, right? So the way you do is this int temp We want to store temporarily the pre-val. Before we think of this, I can just say, hey, array of priv is equal. This is the way of swapping it, right? Array of key, okay? And then array of key, I'm gonna swap it as array of pre. But now you see the problem again. When you swap it, because array of pre is already updated, I want to call it temp, okay? And then here I want to say, hey, int temp equals what? Basic array of pre. So that's how you keep the temp variable. And later on, what you want to do is, because you swap it, you just decrement both the basically key and pre, right? So key will be the pre value, which is decremented by 1, as you see, and pre is going to be decremented by 1. So I hope you see sort of this is the algorithm. So if it keeps going back and forth, it's going to, so these key and pre indexes kind of keep updating like this, and those neighboring values are going to be keep comparing each other. And later on, after you finish out, I want to return it the array. So hope that works. Let's instantiate our public static void main method, take string args by default, and then later on what I want to do is I want to say int array equals, because array is going to pass me as a reference, right? You can definitely try doing it. You can definitely need to basically declare first. This is a better way of just reading it right after. And result is I'm going to get the return solution dot insertion sort array. Oops, make sure you don't have typo. Array. So this insertion sort is the method of this class getting access by the static variable, and then this basically line takes the array as integers and it's going to sort it. So hopefully the result is going to be stored as 1, 2, 3, 4, 5, 6, 7, 8, 9. This is in order list. You cannot print array list. I'm sorry, the array in Java directly. So you need to loop through, and then you need to figure out how to print it out. So for int equals 0, I is smaller than array dot length dot length, right? And then I++. So in this case, I guess it should be just result dot length I++, because in this case the array is named as a result, and system dot out dot println result I plus, I'll say just one space so that you can kind of see comfortably. I'll say result is print that way. So I think that's it. Let's try it and see what's returning. Not a statement. For int I equals 0, I equals 0, I plus 1. Line 33, I have a problem. So let's print out. Do I return 0? Should I return anything? Nope. That ends there. Oh, I'm sorry. So I don't need to close this one, right? Maybe do I need to? Oh, I think I need to do it, right? Yeah. So what's the problem then? This for loop is closed there. There. It's not a statement. 1, 2, 3. Not a statement. Int I equals 0. Oh, I'm sorry, because this was this typo, right? Int I, it should be started with I. And solution dot cannot find symbol. Solution dot insertion sort. Solution dot insertion sort. So that's that was typo. 1, 2, 3, 4, 5, 6, 7, 8. What if I had 9 at any point and 10 at any point? Is it gonna still sort it? 1, 2, 3, 4. 1, 2, 3, 4, 5, 6. There's no 6. Okay, let's write 6. 6. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. Hopefully. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. There you go. Boom. So this is insertion sort in Java. And still time complexity is order n squared, because we need still or 2 looping going on. So I would say definitely this is not the ultimate or the optimal way of sorting it, but I hope you kind of see the algorithm and how you can implement this in Java. And I hope you like this channel, and hope you have a great day. Thank you.